Have you ever stepped outside on a clear night, locked eyes with the moon, and just felt completely confident that you are seeing it exactly where it is right in that specific moment?
I mean, yeah, it's a totally natural assumption.
Right. But today, we are going to completely shatter that illusion for you. Because, well, you aren't actually looking at the moon where it is right now.
No, not at all. You're essentially sitting inside the movie theater of your own brain, just, watching a delayed broadcast.
Exactly. So welcome to this deep dive. Today, we are exploring a really fascinating, highly analytical Japanese blog post.
Yeah, it's titled Draft, Mr. Einstein's Slacking 150 Lunar Image and Significant.
And the mission here is to unpack this author's, frankly, provocative claim. They are arguing that this simple biological illusion, our brain's failure to process visual lag, actually tricked Albert Einstein and Hendrik Lorentz into breaking modern physics.
Which is massive. I mean, the stakes the author sets up here are enormous. We're looking at a fundamental critique of how human beings process information delay, which the source just simply calls lag.
Just plain old lag.
Right. And the argument is that even the most rigorous, brilliant scientific minds in history might have fallen victim to their own visual processing habits.
Wow.
Yeah, it challenges the foundational mechanics of special relativity by suggesting that early physicists basically confused a mathematical map for physical reality.
And I am so fascinated by how the author tackles this, because they don't start with complex equations, right?
No, not at all.
They start with linguistics and human biology, really, to explain how we see the universe versus what is actually physically happening.
Yeah, they use these linguistic terms, significant and signifié.
Right, which I know come from linguistic theory, specifically from Jacques Lacan.
Exactly. And those two terms are really the entire engine of this critique, because we have to separate the universe into two distinct categories.
Okay, so break those down for us.
Sure. So the signifier is the raw physical reality. Out in the vacuum of space, reality is it's just photons of light traveling over massive distances. And when those photons finally arrive, they hit your retina like this completely random delayed spray of raw data points.
So it's just pure, uninterpreted static, just physical light striking a biological sensor.
Correct. But your brain, it doesn't let you experience reality as a chaotic spray of delayed photons.
Thank goodness for that.
Right. The moment those photons hit, your brain instantly generates the signified.
Okay, the concept.
Yes, the concept, the meaning. It's the cohesive two-dimensional image that your consciousness actually experiences. It takes all that scattered, delayed data and just renders a smooth, real-time image in your mind.
And the source illustrates this beautifully with a text analogy. So imagine looking at a piece of paper with clusters of black ink dots on a white background.
The raw physical reality.
Exactly, the significant. But if you read Japanese, the second you look at those specific dots, your brain instantly screams, neko, which is cat, or, dog.
You literally stop seeing the dots.
Right. You jump instantly into the symbolic realm and you just see the meaning.
And that jump is instantaneous and it's completely invisible to our conscious mind.
So when we apply that exact same mechanism to the night sky,
we look up, our brain takes the delayed light, renders a cohesive 2D image of the moon on our mental movie screen, and we instantly jump to the meaning.
Which is the moon exists right there, right?
Exactly. We completely ignore the delay.
But the reality is that those photons took over a second to get here. I mean, if we look at the sun, that's an 8-minute delay.
Yeah.
So is my brain essentially acting like an autocorrect for my eyes? Like it just swaps out raw, laggy data for a neat present tense picture.
Autocorrect is close, but I'd say it's more like a live video renderer. It doesn't just fix typos, right? It builds a completely cohesive, instantaneous illusion out of scattered, delayed data.
Oh, wow.
And this renderer is relentless. It hides the lag to give you a smooth, usable experience of reality.
Which is great if I'm, trying to catch a baseball or walk down the street without tripping. But if a theoretical physicist is looking through a telescope and assumes they are seeing the universe in real time,
then their entire mathematical foundation is going to be fundamentally flawed.
That is wild.
That is the core accusation here. The author argues that early physicists built models of the universe completely blind to the fact that their biological renderer was hiding the lag.
They trusted the image their brain generated over the physical reality of the delayed data.
Exactly. And this leads right into the author's critique of the mathematical maps that physicists use, specifically the Cartesian coordinate system.
Right, because physicists are obsessed with math And they rely on this massive three-dimensional grid to chart the universe.
But the flaw with that Cartesian grid, according to the source, is that it represents a simultaneous universe.
What does that mean exactly?
Well, on that mathematical grid, you can assign a single moment in time to the entire board. At time equals 0, the whole grid is at time equals 0. It's this God's eye view of reality where everything is happening instantly and concurrently.
Ah, okay. But the author brings in a cartography analogy to show why trusting a flat map like that is incredibly dangerous.
Yeah, the map is not the territory.
Right. Look at a standard Mercator projection map of the Earth. If you draw a straight line from Tokyo to Hawaii on that map, it visually represents the shortest possible distance between those 2 points.
It looks mathematically perfect on the paper.
Yeah.
But if you grab a three-dimensional globe and try to find the shortest path, it is not a straight line across a flat plane.
It's curved.
Right. It's a curved line, known as the Great Circle Route, because the physical sphere of the Earth bulges out. The mathematical map distorted the physical reality.
Because light has a speed limit, there's a delay in the universe. You can't just, slap a universal timestamp on everything.
No, you really can't. Different points on a grid reach the observer's eye at completely different times.
Right.
Imagine standing on Earth and receiving light from a star 1 light year away and another star 10 light years away at the exact same moment on a Cartesian grid. If you record them at time equals 0, you are flattening a 9-year physical delay into a single simultaneous event.
The map ignores the lag.
Precisely.
So here's a real-world analogy. It sounds like early physicists were trying to play a really fast-paced, competitive multiplayer video game using the game's static, printed paper map.
Oh, that's a great way to put it.
Right, like they're doing all their calculations based on where the map says the other player should be, completely forgetting that network ping and server lag mean the other players aren't actually there anymore.
That captures the mechanism perfectly. If you shoot at where the player appears on your screen but their ping is high, the data is old.
You miss.
You miss. The map lied to you because it didn't account for the travel time of the information. Now imagine running one of the most important physics experiments in history using a map that ignores server ping.
It's going to completely break.
It did break.
And that brings us to the Michelson-Morley interferometer experiment, which the source highlights as the moment the map officially failed.
Yeah, this is huge.
Let's really dig into how this experiment worked, because it wasn't just measuring light, was it?
No, it was trying to measure the Earth's movement through what they thought was the ether of space. The setup is crucial here. Michelson and Morley built a device that splits a single beam of light into 2 separate beams.
Okay, 2 beams.
One beam shoots forward in the direction the Earth is moving through space, and the other shoots out at a perpendicular 90-degree angle. Both beams hit mirrors and bounce back to a central detector.
So the logic was kind of like racing 2 swimmers in a flowing river, right?
Exactly.
If one swims straight upstream against the current and back, and the other swims across the current and back, the upstream swimmer should take longer.
Right. They expected the light beam traveling in the direction of the Earth's motion to be delayed by the current of space, which would create an interference pattern when the beams reunited.
Okay.
They mapped the entire experiment out on their simultaneous Cartesian grid, calculating exactly what the difference in return times should be.
But when they ran the experiment,
the return times were identical. There was no difference.
None at all.
None. The speed of light was constant, regardless of the Earth's movement.
Man, that must have been a massive crisis. I mean, their math said one thing and the physical universe did another. The Cartesian God's eye view completely fell apart.
It really did.
But here is where the author's critique gets genuinely scathing. Because if your mathematical map is broken by the physical results, you should throw out the map, right?
You would hope so, yeah.
You draw a new model that accounts for the fact that light lag doesn't behave like a river.
But the source argues that Hendrik Lorentz and later Einstein did the exact opposite. Instead of throwing out the Cartesian grid, they created a mathematical patch.
They forced the universe to fit the broken map.
Yes.
We actually have a translated radio segment from the source, and it says it bluntly. Instead of realizing their mathematical grid was flawed by lag delay, they just decided the physical universe was shrinking to make the math work.
And this is the birth of Lorentz contraction. Let's look at the basic math they were trying to save here. Velocity equals distance divided by time.
Okay, pretty standard.
The experiment proved the speed of light was completely constant. And for the outside observer, The time didn't seem to change. So, to keep the mathematical equation balanced, Lorentz decided the only remaining variable, the distance, must have physically changed.
Wait, so he theorized that the entire physical apparatus literally shrunk in the direction of its motion through space.
That's the claim.
Like the physical metal of the interferometer compressed just enough to make the light paths perfectly equal out on their simultaneous grid.
Yeah. But the author views this not as a physical reality, but as a software patch.
Wow.
Rather than bending their mathematical map to account for the complex visual lag of measuring moving light, they bent the physical universe itself to save their Cartesian geometry.
I have to push back here, though. On behalf of anyone listening who really knows their physics, relativity isn't just a theory on a chalkboard.
Yeah.
It has real, practical applications. I mean, GPS satellites orbiting the Earth literally have to account for time dilation and relativity to keep our maps accurate.
Yes, they do.
If they don't adjust for Einstein's math, the GPS drifts by miles. So, how does the author reconcile calling this a bad map when the technology built on it actually functions in the real world?
It's a vital question, but the author isn't arguing that the predictive math of relativity is useless.
Oh, okay.
Think about it. A patch on a software program still stops the program from crashing, right?
Yeah, that's true.
The equations of relativity successfully predict the outcomes of these experiments. What the author is attacking is the physical explanation of those equations.
I see.
The math works as a predictive tool, but claiming that physical space is actually squishing or time is literally slowing down. That's confusing a mathematical workaround for a physical truth. They patched the symptom without understanding the underlying disease, which is visual lag.
Okay, I follow the distinction, but how did Albert Einstein miss the disease? I mean, he's the poster child for modern genius. How did he fall for this illusion?
Well, the source claims Einstein was slacking in his conceptualization, specifically in his really famous train thought experiment.
Right, let's visualize this train. So Einstein is sitting on a moving tram in Bern, Switzerland.
Yep.
And he imagines a beam of light shooting straight up from the floor to the ceiling. Because he's moving along with the tram, he assumes the light travels perfectly vertically relative to him and the physical space of the train.
And it seems logical, right? If you toss a coin up in the air while you're riding a smooth train, it falls straight back down into your hand.
Sure, Newtonian mechanics tell us objects carry the momentum of their environment.
Exactly. But the author argues Einstein fell back on his everyday biological assumptions, his signifié.
He trusted his brain's renderer.
Right. Instead of the raw physical facts of how light operates independently of matter, the significant.
And to prove this, the source brings in a massive historical discovery by an astronomer named James Bradley. Stellar aberration.
Yes. Decades before Einstein, Bradley was trying to measure the distance to a star called Gamma Draconis. And in doing so, he proved that light travels in a straight line through the medium of space, completely unaffected by the movement of the source or the observer.
Meaning light doesn't carry the momentum of the train.
Exactly the opposite of the coin toss. Bradley discovered that because the Earth is moving through space while the starlight travels down the tube of his telescope, he actually had to physically tilt his telescope diagonally to catch the light.
Wait, really?
Yeah, if he pointed it straight up, the Earth would move and the light would just hit the side of the telescope tube before ever reaching his eye.
I need to use an analogy to make this concrete for you guys listening. It's like standing outside in a rainstorm when there is zero wind.
Okay, I like this.
The rain is falling straight down. If you stand still, you hold your umbrella perfectly straight up to stay dry. But if you start sprinting forward through that exact same straight falling rain, the drops suddenly appear to be coming at you diagonally from the front.
Yep.
You have to tilt your umbrella forward or you get completely soaked.
That is stellar aberration perfectly explained. The rain or the light is traveling straight, but your movement changes the relative angle of impact. Now, apply Bradley's discovery back to Einstein's moving train.
Okay, so if the light beam doesn't carry the momentum of the train, and the train is moving forward, the light shooting from the floor to the ceiling cannot travel perfectly straight up relative to the tracks outside.
It cannot. As the light travels upward, the ceiling of the train is moving forward. For the light to actually hit a specific point on the ceiling, it must travel on a diagonal path through space.
Oh, wow.
And more importantly, for an observer standing outside the train watching this happen, the speed of the train fundamentally changes the angle at which those light rays eventually hit their retina.
The source notes that depending on how fast you're moving, the angle of incoming light from 2 points in your visual field might shift drastically. Like, from a narrow 30 degrees to a wide 110 degrees.
Exactly. The geometry of what you actually see physically changes based on speed.
But Einstein ignored the aberration. He assumed the light traveled perfectly vertically inside the train.
He did. And by failing to calculate the changing angle of light hitting the retina, the visual lag, he built the foundation of special relativity on a flawed premise.
Because he assumed the light path was shorter and straighter than it physically was for an outside observer, he had to invent time dilation to make the math balance out.
Basically, he forgot to tilt his umbrella and compensated by claiming time itself slowed down.
That is insane. So if space contraction and time dilation are really just massive mathematical band-aids over a failure to calculate visual lag, what is the alternative? How does the author propose we fix the map of physics?
Well, the author suggests what they call a simple trick. We have to completely abandon the Cartesian God's eye view.
Just throw it out entirely.
Yeah, we can no longer pretend we can map the universe simultaneously. Instead, we must center the mathematical model entirely on the observer's camera eye, the retina.
Okay, so what does a retina-centered model look like in practice?
It requires treating the distance of an object strictly as a function of the time it takes the light to reach your eye. You map the true territory by tracking the delay. Time becomes the depth in your visual field.
So instead of trying to measure the whole universe at once, we only calculate reality based on when the mail finally arrives in our specific biological inbox.
Yes.
We track the incoming photons, the dot pixels, and strictly align them to the timestamp of when they actually hit the retina.
Exactly. And when you apply this retina-centered model, the paradoxes vanish. If you account for the visual lag and the specific angle of incoming light, the interference patterns of the Michelson-Morley experiment make perfect mathematical sense. Yeah, you don't need the physical metal of the interferometer to miraculously shrink. The length of the physical paths never changed. The delay in the light reaching the observer simply created the illusion of a difference.
But what about massive cosmic phenomena? The source mentions blue shift and red shift. How does an inbox model explain things like galaxies stretching out as they move away from us?
Let's break down the Doppler effect first. When an ambulance drives toward you, the sound waves compress and the pitch goes up, right? When it drives away, the sound waves stretch and the pitch goes down. Well, the same thing happens with light. When a star moves toward us, the light waves compress and appear blue.
Okay.
When a star or galaxy is moving away rapidly, the light waves stretch out, pushing into the red spectrum. Physicists use redshift as proof that the physical fabric of space is stretching and expanding.
But the author's going to argue that's just another map error, aren't they?
Yes, they are. The author points out that under the retina-centered model, redshift is just visual lag geometry. Remember the Japanese letters we discussed earlier?
The Neko and Inu.
Right. Imagine reading those letters while flying backward away from the page at immense speed. Because you are moving away from the incoming light, the pixels of light carrying the image of the letters take longer and longer to reach your eye.
Ah, so the data is stretching out across the delay.
Precisely. By mapping strictly what hits the retina and when, the simple trick naturally explains redshift.
That makes so much sense.
The object appears physically stretched in our visual field because the delayed light is hitting our retina at an altered angle and frequency. It is a profound optical illusion caused by velocity and lag, not a bizarre physical transformation of space itself.
It is stunning how much of this boils down to simply acknowledging the limits of our own perception. If we ignore the lag, if we ignore the travel time of the data, we end up inventing magical shrinking boxes and stretching universes just to explain our own biological rendering errors.
The ultimate takeaway here is that our physical models of the universe are entirely constrained by the limits of our biological and mechanical data collection.
And that has incredible implications outside of theoretical physics.
Right.
I mean, why does a deep dive into Japanese blog posts about Einstein matter to you listening right now?
Right.
Because it is a stark reminder about the danger of confusing the models we use with the reality we actually live in.
The map is not the territory.
Exactly. Whether you are looking at a complex predictive spreadsheet at work, a GPS route on your phone, or just staring up at an image of the moon, you are looking at a delayed representation.
Yeah.
You are looking at a model constructed from old data. You're never looking at the thing itself in real time.
And if we accept the premise of this critique, it leaves us with a really massive puzzle to consider.
I'm ready for it.
If concepts as globally celebrated as special relativity, time dilation, and the shrinking of space are actually just mathematical band-aids designed to cover up a bad map, what else are we missing?
Oh, man.
What other fundamental truths in our daily lives our scientific consensus, or even the structures of our society are actually just clever workarounds. What else have we accepted as an absolute law of reality simply because our brains hid the lag?
That is exactly the kind of question that changes how you look at the entire world. Keep questioning the maps you're handed, and remember that your brain is the world's most convincing video renderer. Enjoy the movie theater in your head, but don't forget it is always a delayed broadcast. Thanks for joining us on this deep dive.